Let A and N be the set, find the union of these sets and prove it. So the union of these sets is 5 to infinity. To prove this, we're going to prove two things. We're going to prove that the union of these sets is a subset of 5 to infinity, and 5 to infinity is the subset of the union. So for part A, let's say we get an element within the union. And the goal is to prove that this x is in 5 to infinity, so x is greater than 5. So we know that, or from this, we know that x is greater than or equal to 5 plus 1 over n squared. We also see that 5 plus 1 over n squared is strictly greater than 5. If you combine these together, you get x greater than or equal to 5 plus 1 over n squared, which is greater than 5. So in this case, we get x greater than 5. We're done proving for the set. For part B, we need to prove that 5 to infinity is a subset of the union of the sets. So let x be a member of 5 to infinity, and the goal is to get x to be greater than or equal to 5 plus 1 over n squared. So we know that we see 1 over square root of x, and we know this is true because x is within 5 to infinity. This will never be invalid. And by the Archimedes principle, we get 1 over square root of x is greater than or equal to some number n, where n is within the natural numbers. Okay, so from here, we square both sides. We see that 1 over x is less than or equal to n squared. Rearranging this equation, we get 1 over n squared is less than or equal to x. So with this, I'm going to add both sides by 5. So we get 5 plus 1 over n squared is less than or equal to x plus 5. And we know that x plus 5 is still within 5 to infinity. So we could reduce this down to 5 plus 1 over n squared less equal to x, and that's what we want.